So in today's lessons, we're going to be covering dividing polynomials using synthetic division. So synthetic division is a certain type of division that's very easy to use if you have the correct requirements in the polynomial. So we'll start off with an example. Let's take 3x to the third minus 2x squared minus 150, and then divided by x minus 4. So in this case, your denominator has to have the or in any case for synthetic division, it has to have the polynomial of a degree of 1. Polynomial degree equals 1. And you also have to have your coefficient equal to 1 in the denominator. So in this case, x minus 4 satisfies both of those requirements, so you could use synthetic division on this problem. So first, what you're going to start off by doing is taking your coefficients for all of the variables. So in this case, you have 3 for the x to the third. You have a negative 2 for x squared, because you transfer over that negative side with the number. You have a 0 for x to the first, because there is no x to the first. And then you have a 150 for the normal number. So you're going to write that all down in a line. 3, negative 2, 0, and negative 150. And then you're going to take your second part, which is your denominator, and you're going to set that equal to 0. So x minus 4 equals 0, x equals 4. So you're going to take this x equals 4 and put it in what I call the batter's box. Okay, now that's in your batter's box, you're going to draw a line and bring down your first number. So your first number is 3. What you're going to do is multiply the 3 times the 4. So your first number and whatever's in the batter's box. So in this case, it would be 12. And you're going to add these two numbers. So the negative 2 plus 12 is 10. And you're going to repeat the process. So 10 times 4 equals 40. And then you're going to add, just like we did before, it's going to be 40 again. And then your 40 times 4 is 160. And then you're going to add, and this comes out to 10. So now that you have all your numbers together with your remainder of 10, because that's what was left over when you divided, you're going to look back to your original equation. And this had the coefficient, this had the degree of x to the third. So you're going to go down one degree. So in this case, it would be starting x squared. So you're going to take your 3, and you're going to make it 3x squared. Because essentially what you're doing is you're dividing an x minus 4. So if you're taking out an x minus the 4, logically you're going to go down an x because you're taking one out of the problem. So then you're just going to go down the ladder, and then you have 10 to the x, or 10x, plus 40, and then 10 is your remainder, because that's what was left over as you were dividing. So it's going to be 10 over what you had in the original denominator. So in this case, it's x minus 4. And then that is your final answer. So in some cases, the coefficient in the denominator is not always 1 like it was in the first example. And the steps are similar, but you just have to adjust a little bit. So let's look at the example 8x to the third plus 12x squared minus 4x minus 6. Let's say divided by 2x minus 1. So in this case, you would take the coefficient of the x, which is 2, and divide everything by 2. Or I'll use a different color so it's more noticeable. Divide by 2, and then everything. So this leaves you with 4x to the third plus 6x squared minus 2x minus 3 divided by x minus 1/2. And now you have it so that the coefficient in the denominator is 1. So you do the same steps as before, where you have your coefficients. You'd rewrite them, so 4, 6, -2, and -3. And then you have your denominator, and you just want to solve for x, set it equal to 0. So in this case, it's x equals 1/2. And then you take your x, you put it in the batter's box, and you start the problem. So you draw the line, you bring down the 4, and then you multiply by 1/2, and that equals 2, and then you add. So 8 times 1/2 is 4. Bring it down, multiply 1, and then you have -2. So having -2 as your remainder, we're going to go back up to the problem, and you can see we divided everything by 2. Now in this case, for the remainder, you have to multiply what you originally divided it by. So in this case, it would be -2 times +2, and then over your denominator. So 2x minus 1. So this equals -4 over 2x minus 1, and then that is your complete remainder. Don't forget to do that step, because then your remainder would be wrong if you did. So then you're going to take your 4, and our original coefficient was 3, so you're going to take it down 1 and make it 2. So 4x squared plus 8x plus 2, and then minus, or you could say plus a -4 over 2x minus 1, and then that is your final answer.